This is Math 118, sections 2.6 and 2.7. I'm going to do this in 3 videos. This is part 1 video for absolute value equations and inequalities. When you see an equation or an inequality, and it has these straight up and down lines, that represents absolute value. Absolute value means absolute distance on the number line, or the distance on the number line. This is explained further in class in the lecture. This video is mainly to reinforce the definitions and how to solve the problems. So this first example is an example of an absolute value equation. This next example is an example of an absolute value inequality because it has a less than sign. And this third example is also an example of an absolute value inequality because it has a greater than sign. Now for all absolute value problems, before you can actually apply the rules, the absolute value part of the problem has to be isolated or by itself on one side. So for example, this problem here, 2 times the absolute value of x plus 5 minus 6 equals 10 cannot be solved this way it is written because the absolute value is not the only thing that we see on the left side. We see this 2 right here, and we see this minus 6. Before you do anything, before you even go to find the rule, you need to move the 2 and the 6. First thing you do is you add 6. It is an equation. You can do whatever to an equation as long as you do the same thing to both sides. When I add 6 to the minus 6, it equals 0, so they cancel out. And on the right side, I get 10 plus 6, or 16. I'm still not where I need to be in order to solve this problem because the absolute value, again, is not the only thing I see on the left side. There's still this 2 out in front. Now that 2 sitting there means multiplication. That's 2 times the absolute value of x plus 5. So in order to get rid of the 2 or move the 2, the opposite of multiplication, or the inverse function, is division. So I'm going to divide both sides by 2. Cancels out. I get absolute value of x plus 5 equals 8. Now, this problem right here can be solved by applying the rules. Notice that I see absolute value, and that's it, equals a number, and that's it. For the next example, which was the absolute value of 3x minus 4 plus 2/3 is less than 5, again, I cannot solve this absolute value inequality because this plus 2/3 is on the same side as the absolute values, and the absolute value has to be the only thing you see on that side. So in order to move the 2/3, or to get rid of the 2/3, we need to subtract 2/3 from both sides. When that happens, now you have absolute value of 3x minus 4 is less than, let's see, what's 5 minus 2/3? I have to get common denominators of 3. 3 goes 1 to 3. 3 times 5 is 15. 15 minus 2. Okay, so that's 13/3 goes here. Now notice, all that I see on the left side of my inequality is absolute value, and on the right side is a number. So now this problem is also ready to solve. The third example, minus the absolute value of x plus 3 greater than 16. almost looks like we're there because all I see are absolute values, but no, there's a minus sign outside of the absolute value that cannot be there. So I need to get rid of that minus sign. Now that's the same thing as minus 1 times the absolute value of x plus 3 is greater than 16. So what you do in this problem is you divide both sides by minus 1, and you get absolute value of x plus 3 is less than a minus 16. Don't forget that whenever you multiply or divide by a negative number, the inequality sign changes. Now this problem is also ready to solve because the absolute value has been isolated. In part 2, I will write down the rules for